So now let's move on to the another time-dependent source or cause of prestress loss, which is what we call the shrinkage loss, usually designated as SH. So we know from our previous discussions that shrinkage is the movement of water, specifically moving out from the concrete. So that movement of water from the concrete tends to uh, change its volume, thereby producing what we call shrinkage. And that shrinkage, that phenomenon, that scenario, that shrinkage that is being experienced by the concrete when water moves away or moves out from it, that scenario results to what we call shrinkage loss that is being experienced by the pre-stressing reinforcement. So approximately 80% of shrinkage takes place in the first year of life of the structure. And the average value of ultimate shrinkage strain in both moist cured and steam cured concrete is given as 780 times 10 to the negative 6 inch per inch in ACI 209R-08 section A.1.1, which is this. This is ACI 209.2R-08, which is the guide for modeling and calculating shrinkage and creep in hardened concrete reported by ACI Committee 209. So if you will look on this particular provision inside the ACI 209, you can see here that it is specified that the ultimate shrinkage strain, which is the symbol, is equal to 780 times 10 to the negative 6 mm per mm or inches per inches. So whichever unit is used, actually there is no unit for strain. We just usually indicate uh, a unit here for calculation purposes. So this average value is affected by the length of initial moist curing, ambient relative humidity, volume surface ratio, temperature, and concrete composition. So to take such effects into account, the average value of shrinkage strain should be multiplied by a correction factor gamma SH, which can be found on uh, ACI 209 R-08 section 8.1.1. For values, you can find the values of this at ACI 209R-08 section 8.1.1. So to account this effects here, the factors here that usually affects the average value of the ultimate shrinkage strain, it must be multiplied by a correction factor gamma SH. So therefore, the correct shrinkage strain must be equal to this value specified by the ACI code times a correction factor gamma SH. So for the case of PCI, the Pre-Stress Concrete Institute, so a standard they stipulated for standard conditions an average value for nominal ultimate shrinkage strain equal to this. So for ACI, the ultimate shrinkage strain is equal to this 780 times 10 to the negative 6. 780 times 10 to the negative 6. But for PCI, for Pre-Stress Concrete Institute, uh, they specified that the ultimate shrinkage strain must be equal to 820 times 10 to the negative 6. By the way, the meaning of PCI is precast or pre-stressed concrete institute. So uh, they are usually the governing body for the design of pre-stressed concrete members. So for us to be able to calculate the actual pre-stress loss due to shrinkage, we can use this formula here. If uh, if epsilon sub sh is the shrinkage strain, after adjusting for relative humidity at volume to surface ratio V over S, the loss in prestressing in pretension member is equal to this. So this is the formula for finding the prestress loss due to shrinkage. You just have to multiply the adjusted. So take note, this must be the adjusted shrinkage strain. It must be multiplied by the modulus of elasticity, obviously by the prestressing reinforcement. So if you can notice on this formula, it's just similar to the Hooke's law. Stress is directly proportional to the strain with a constant of proportionality equal to the E, which is again the modulus of elasticity of the prestressing reinforcement. So that is how you can find the prestress loss due to shrinkage. You must know first the magnitude of this adjusted shrinkage strain. For post-tension members, the loss in prestressing due to shrinkage is somewhat less since some shrinkage has already taken place before post-tensioning. So as we all know, post-tensioning is done after the concrete already attained enough strength. Actually, it can be up to the point wherein the concrete already attained its 28-day compressive strength. So because of that scenario, uh, shrinkage already occurs on the concrete even before the application of post-tensioning. So thereby, when you already apply post-tensioning to the concrete element, the shrinkage that will be experienced by the concrete at that uh, stage of prestressing, which is actually the actual imposition of post-tension force, the shrinkage that will be experienced by the concrete at that stage will be obviously uh, already less in magnitude because the shrinkage already occurred even before the application of the post-tension force. So if you will now apply the post-tension force, uh, tendency is there will be less uh, prestress loss due to shrinkage, again because most of shrinkage already occurred even before the application of the post-tension force. That's why loss due to uh, shrinkage is less for post-tension members compared to pretension members. So there are actually two ways that we will study here to find the adjusted shrinkage strain to compute for the pre-stress loss due to shrinkage. So the first method that we will study is the time-dependent method, since we all know that shrinkage is actually a time-dependent cause or source of pre-stress, just like creep and still relaxation. So the adjustment of shrinkage losses for standard conditions is being expressed as a function of time t in days after 7 days for moist curing and 3 days for steam curing. So the formula for that adjustment of shrinkage losses is equal to these formulas that will be specified here. So take note again, these formulas that we will specify here is just for standard conditions of humidity, which is equal to approximately 40%. So for the case of moist cured concrete at any time t after age 7 days of the concrete, the formula for the adjusted shrinkage strain is equal to this. So the product of this factor and the ultimate shrinkage strain, which can be which can have a value equal to this if local data are not available. So for the case of steam cured concrete at any time t after age 1 to 3 days, the adjusted shrinkage strain with respect to the uh, time dependent adjustment that we will do here is just equal to this formula. So again, almost similar to this formula, we just change 35 to 55. for the case of steam cured concrete. And the value of the ultimate shrinkage strain here can be used as 730 times 10 to the negative 6 if local data are not available. So that's for standard conditions of humidity only. So for other humidity, a correction factor must be applied to these values that you will compute here. So you just have to multiply these values that you will be computing here by these correction factors that we will specify here. So for the case of the relative humidity is between 40 and 80, 80 inclusive, 80%. The correction factor that must be used is equal to this. And for the case wherein the relative humidity is between 80 and 100%, 100 inclusive, the formula for correction factor that must be used is equal to this. So again, you just have to multiply these values by these correction factors. So if the relative humidity is not standard, meaning it's not approximately equal to 40%. So that's the first method for computing the adjusted shrinkage strain to compute the pre-stress loss due to shrinkage. So there is another method specified by ACI ASCE which uh, compute the shrinkage loss using this equation that we will specify here. So if the relative humidity RH is taken as a percent value, and the V over S ratio effect is considered, the volume over surface ratio effect is considered, the PCI general expression for loss in pre-stressing due to shrinkage becomes equal to this formula with KSH equal to 1 for pretension members. And you can also use this formula if the V over S is expressed in inches. So if the V over S, the volume over surface ratio, is expressed in terms of mm, you have to use this formula. This is actually for the case of SI units. And for the case of US customary units, you can use this formula here. So for the value of KSH for post-tension members, you can refer to this table, which can be found from PCI, from Prestress Concrete Institute. So you can see here that the value of KSH for post-tension members is dependent on the time from end of moist curing to application of Prestress in days. So again, for pretension case, KSH is just equal to 1. For post-tension, you can use this table for finding the magnitude of KSH for any given time from end of moist curing to application of Prestress.